right, so we're focusing in on the x cosine x. So if we go back up to our table, so I'll kind of scroll up there. Oh, too far, too far. All right, so where would we see something that looks similar to x cosine x? So some exponent of x in some trig function, and the closest one we can see is 11. Now in that one they have an x squared, whereas we just have an x. So that means we don't have to worry about the squared terms. We just worry about the x and the constant terms in that. But it's going to have that sort of general feel to it. So let me go back down here. So our particular format would look like ax plus b cosine x plus cx plus e sine x. And this kind of a silly time to bring this up. I felt like I should have brought this up earlier. Why am I not using the letter D? Why am I purposely skipping D when I'm writing these things out? And the answer is, in an earlier lesson, we talked about how the letter D, capital D, represents differentiation. So you kind of don't want to pick the letter D as a variable because it might be confused with an operation, so you're doing an actual process there. But anyways, if you had that question and you were wondering in the back of your mind, like, why is he not using this? Well, now I've just addressed it. Okay, so I kind of feel like the directions are missing. So we're still trying to find what the form of the particular solution looks like rather than the actual solution of the differential equation. So you can appreciate that these take a while. Like there's a lot of algebra involved and it takes a couple of minutes. So the key skill that I'm more worried about at the start here is recognizing what the particular form looks like. Yes, during homework and on a test, you'll have to go through the mechanics of actually finding the general solution. But I also recognize that I can't put too many of these types of problems on a test because one problem is a good 20-minute algebraic exercise. So, anywho, so this question, determine the particular solution. What would the format of that look like? So what would we look for the format of y of p? Or yp? Well, we have just a large pattern here. So, and this is where, again, you probably want to go back to that chart in case you're like, what? Okay. So, because of x squared, I know my particular format is going to look something like a x squared plus bx plus c. And because of the sine of 2x, then I know the format for those terms are going to look something like e cosine 2x plus f sine of 2x. And then for the x e to the 6x, I know that's going to look something like g x e to the 6x plus h e to the 6x. Again, you can imagine if we actually were to do that solution, that would be, I don't know, 45 minutes of our life we're not getting back. But let's see, we can kind of clean this up a little bit. So not too much though. So ax squared plus bx plus c plus e cosine 2x plus f sine of 2x plus, I can factor an e to the 6x out and get gx plus h e to the 6x. So that would be the general format of our particular solution.